Alright, chapter 16, hazardous locations. Hazardous location, chapter 16. Objective, distinguish among various classes of hazardous areas. Summarize ignition and combustion principles. Secretary, define hazardous areas. Identify hazardous areas based on the code. Specifications found in Article 500. It says safety is important consideration on any project. Workers must take precautions to avoid situations where injury or damage can occur. When installing electrical systems, the state of the system, which parts are energized and which are not, must be known at all times. So hazardous areas, what's on, what's off, where is it? Why? Well, all this can cause a problem, so we want to make sure we're minimizing any hazards. Excuse me. I don't know about this. This rain brought my allergies on for some reason, so you gotta excuse me. Can't stop my nose. This says the systems must operate safely after it is installed. For systems that operate in a hazardous area, the code requires that specific components and methods are used. A hazardous area is an area where conditions exist that could cause an explosion. Okay, so a hazardous area is an area where conditions exist that could cause an explosion. What causes an explosion? Okay, well you have to have something that ignites something. So your three elements that can make this is your explosive substance. Okay, so what's in a hazardous area? You're working in an area, you got gases, fumes in the air, around a refinery, an area where they're producing or where they fill up these tanks, oxygen tanks, acetylene tanks, or whatever they type. Guess what? That is a hazardous area. Anytime an explosive substance is present, it's a hazardous area, so we have to be very careful with it. Okay, so we have to have an explosive substance, a gas station. Okay, get around the gas pumps. That's a hazardous area. Has to have oxygen, air, and a source of ignition. Okay, a lot of times we can't do anything about the first two. So what we have to do is control the source of ignition. This is where our part comes in. So it says one of the primary sources of ignition is electricity. Okay, so we have to. That's what we have to control. So we have these things that we have to take care of. Excuse me, somebody's talking to me. Okay. It says devices such as receptacle, power plugs, push button stations, motor starters, circuits. Breakers often produce an arc during their normal operations. Okay. Other items such as motors, lamps produce heat. Uninsulated conductor can also be a source of ignition. Oops, let me just jump. So we have to make sure that we take care of these areas. And then it says when installing electrical systems in hazardous areas, every effort must be made to prevent accidental ignition of flammable substance. Following the recommendations, rules, and requirements of the codes and other authorities is crucial in electrical safety. So the code tells us how we install this. The inspector comes by, and then the inspector tells us, it was done according to the code, or if a local jurisdiction might have something changed, so you have to find from your local jurisdictions what is their requirements that might exceed what the code requirements are. So what we're trying to do is control the source of ignition. I had some pictures, but I don't remember. So here's an example of some of the hazardous location. Excuse me. Hazardous location. So you can see here's junction boxes. Here's our junction box. Here's the panel board. This could be a motor starter. Here's a reset for the motor starter. Your stop starts. Your switch, you turn it on and off. This may be for switches to turn things on and off. Again, stop starts. Receptacle for a plug. So when you have a receptacle or the plug, it plugs in. When you disconnect it, it has time to discharge. So that's why it has a long neck. The actual receptacle part might be down here. So when you unplug the plug from the receptacle, okay, it has time to cool down before you expose it to the air. And that's why they have long necks on them. Okay, more enclosures. So these are all sealed off. So just to give you an idea of some of the enclosure, panel boards, starters. That would have to go into these flammable areas. Okay, hazardous locations. This says hazardous locations are divided into classes based on the type of explosion material and the area. There are 3 classes. Class 1, flammable explosive vapors or gases. Class 2, combustible dust. Class 3, ignitable fibers. Okay, and then we have a Division 1 and Division 2. So we have 2 divisions that go in. So Division 1 is flammable, ignitable, and explosive conditions during normal operations. So let's say I got a room here and I'm working with gases. So gas is always present because I'm in here all the time. I mean, well, someone's in here working. So then that would be a Division 1. Okay. Division 2 is a flammable, ignitable, and explosive conditions under unusual circumstances. Okay, now let's go back, and this is a secondary room. My primary room where all the work is done is the next door. Okay, when would this would be a Division 2? Why? Well, that problem would only exist, let's say somebody leaves the door open. Okay, so some of the fumes can get in here. Now I have a secondary location that could consist, but it's not the actual work being done here. The work is done somewhere else. So if there's an accident or something and then it comes in here, then yes, but it's still part of the hazardous location. So we can have a Class 1, Division 1, Class 1, Division 2, Class 2, Division 1, Class 2, Division 2. And the same thing for the Class 3, Division 1, or Class 3, Division 2. Okay, so Class 1 would be present at all normal operations. So from the time that somebody punches in, say you only have 1 shift, 7 to 5, or whatever it may be. It's only open from 7 to 5. Well, that's your normal operation. Somebody's there. Okay, so that's a class Division 1. Division 2 is an area in case when something unusual happens. Okay, so let's say we have a door that's always closed between two rooms, so it allows it to stay. And the door gets left open. Well, now the second room may have the fiber, the flammables inside of it. Okay, and then class locations. So class locations contain, and it comes into groups. Excuse me. It says a class 1 location contains an explosive vapor or gas. If this substance is present under normal conditions, the area is classified as a class 1, division 1. If the gas and vapors is only present in unusual circumstance, the area is identified as a class 1, division 2. Class 1 locations are further identified by groups, depending on the type of gas present. Okay, so once we start getting into the groups, you get a class 1 location, and this is gases. This is gases. This says group A is acetylene, group B, hydrogen, fuel gases, over 30% hydrogen, butadiene, acetylene oxide, propylene oxide, acrolein, and similar gases. And then group C, ethylene, ethyl, ether, or similar gases. Group D, acetone, ammonia, cyclopropane, hexane, methanol, methane, natural gas, naphtha, propane, gasoline, alcohol, benzene, butane, ethanol, or other similar gases. So you have your different types, your groups, still under class 1, but they have a different group. Code alert. Flammable fluid liquids, Article 100. Flammable liquids with a flash point below 100 degree F or 38 degrees C, or temperatures above its flash point, or class 2 combination liquid, combustible liquids with a vapor pressure not exceeding 40 psi at 100 degrees Fahrenheit, whose temperature is above flash point. So again, if something, you have something that can ignite at a certain temperature, and then you have to be very careful, especially when it comes to lights. Why? Well, what's going to get up to that heat? It's a light. How many times you can leave a light on for a little while and then go touch the light and go turn it? Even these fluorescent and LED light bulbs, they still get warm. You have to be very careful with that. So class 1's location, approved lighting fixtures mounted and methods. This is class 1, Article 501, class 1 locations contain requirements for wiring method and methods used in these areas. The requirements vary for 2 divisions. Light fixtures must be approved for use at a class 1 area. An unapproved fixture may produce enough heat to ignite gases. The mounting method must also be approved. Normally, fixtures has an explosion-proof wiring chamber sealed off from the land compartment. This eliminates the need to install a separate seal adjacent to the fixture. So again, here's our lights. So here's our chamber where our connections made. Not inside the here, but our connections in here, because this would be all sealed. If you have to get into it, the only place you can get into it is to change a light bulb and to where this is at. So at the factory, they will seal between this chamber and down here to make sure there is no, if there is an arc within here, it doesn't get up and out. Okay, so and this says plugs and receptacles designed to eliminate arcing. So plugs and receptacles must be designed to eliminate arcing outside the explosion-proof enclosures. So I showed you earlier that one that has that long neck. Well, the receptacle's all the way in the back. You have a long neck, so when you unplug the plug, okay, there's a gap inside. It's still sealed, so one is an arc. How many have seen when you try to unplug something while it's still on and you have that arc? Well, the last thing you want is that arc to get out into the air where you have an explosion vapor. You know, it goes, okay. Anybody see the news? What was it? Saturday night, where that where the 11 firefighters got hurt. Okay, somebody walked in there and they said they heard a hissing sound. It was like, get out, and by the time they turned around and run out, you know, the thing exploded. I read that in the newspaper today. So again, when you have the vapors present, something was in the air, and then something created a spark, and it ignited that in the air. Okay. The contacts must not create a spark in an explosive atmosphere. Two methods are used to accomplish this. So let me go back real quick here. So here's some pictures here, some examples. So this has a plug, it plugs in, and it has a gap. Same thing here, you can see the long neck. Okay, so when it plugs in, it seals and you start to break it. Okay, it allows the contacts to cool down. Okay, you can see over here there's a different one. Okay, it closes, but this goes in. You can see all these are enclosed to the end here. So when you go to unplug it, it's got time for the arc to extinguish itself before you pull this out completely. So anytime you're unplugging one of these, I've worked in some of these areas, is you unplug it and wait. You know, it's just as a precaution, is you pull it, you unplug it, before you break that seal, give it a couple of seconds. In case there was an arc, you can feel, and then it allows itself to extinguish itself and then finish unplugging it. When I first got in the trade, we used to go around changing light bulbs at a small refinery. Okay, so again, you can see where the prongs are within the enclosure. So as you unplug it, you have to pull the whole thing out before these are exposed. Okay, so if you unplug it, as you pull it out, you can feel when it leaves, and then you just give it a second. Okay, same thing with these. So it's always wise. Some of these are lockable, so it goes in, and it goes in so far, and then you got to twist it, like you can see this little pin, and sometimes you have to twist it before it, so you have to get it so it has a groove, so where you turn it, then it goes in and plugs in. And in order to get it out, it comes straight out. But so you don't pull it out completely, you have to twist it in order to turn it off. So you can see it has the little wings on the side. So you don't just pull it. Okay, you can see here's a receptacle and here's a tab. So it'll have the tabs. You have to get them adjusted till it goes in. Okay. So it says delay action plugs and receptacles are designed to prevent rapid withdrawal of the plug from the receptacles. This allows the metal contacts to cool before being exposed to surrounding explosive gas, and that's what I was talking about. Receptacle contacts can be designed with an integral switch Contacts are not energized until the plug is fully inserted. This switch is placed on the in the off position before the plug is removed. So again, it could have a switch, and the only way to unplug it is if the switch is in the off position. So you're turning power off, allowing it to. So the switch will not allow you to pull the plug out until it's turned off. Explosion-proof equipment, Article 100 and Section 5025. This is enclosed in case capable of withstanding explosion of specific gas or vapors within. Prevents ignition of specific gas or vapor surrounding enclosure. Operates at an external temperature where the surrounding flammable atmosphere will not be ignited. So some of these boxes, when you put them together, it may have, it's going back, let me go back a little bit. Oops, too much. So this light, even though it has a gasket, somewhere along the line, it may have an area where in case there's an explosion within here. So there's an explosion, guess what, the gas has got to go somewhere. But it's tight enough if there's an explosion so the gap, it can reach and then allow the gases to escape after they cool down. So it lets the pressure come out. You know, because it's, has anybody ever gotten a firecracker thrown inside the can to see what it does to the can? You know, well, the pressure. Yeah, we used to do it a lot when I was a kid. You know, so after the fact, they told us over a stick of dynamite. We got a piece of 3/4 inch rigid, put couplings on both sides, drilled a small hole, filled it up with we picked up all the fireworks that didn't pop from the night before, peeled them open, saved all the powder, put them in the stain, and just got a fuse and lit it. We broke about 10 houses. We broke windows, and the trash can. Well, we couldn't find that. After we stuck the trash can over the thing and blew it up. Okay. About 12 years old. Never did that again. You know, so you have to have something that has to release this pressure. So again, somewhere in here it would have on the seal, it has a gap to allow pressure to escape. It says controllers can also be a source of ignition. Controllers can also be a source of electrical arcs. Therefore, motor control stations, push button switches, circuit breakers, and other controllers must be explosion proof in the Class 1 area. Okay, so I showed you the panels. I showed you the stop starts. So it's a metal case, metal box, and it's got a cover. This is all rigid. It's all metal. It says sealing conduits, fittings called seals must be installed in a Class 1 area. Seals are filled with an approved seal compound that prevents an explosion from moving through the conduit. Seals are installed in two situations. So here's our seal. One would be a horizontal, one would be a vertical. So if you got a pipe going this way, your pipe going this way, you can seal. I have those two in the classroom. Sometimes it has a pin so it can allow pressure to escape. But here's sealed off. Once it's sealed off, there's something down in here. It's not going to go anywhere. Where these, once you get your conduit in, once you pull your wires in, so I'm going from a non-hazardous room to a hazardous area, or if I'm going box to box, okay, I'm going box to box. So it says conduit attached to an enclosure where arcing device tap terminals and splices or high temperature devices are housed must be sealed. The seal must be installed within 18 inches of an enclosure. It isolates. A seal is placed where the conduit passes from a hazardous area to a non-hazardous area. Factory seal devices where the seal is designed into the unit eliminates the use of hand poured seals. This saves time and money. The installer simply connects the pigtails or the terminals in the factory seal unit. You just plug it in here, plug it in there, and then it seals off the area. I've never used them. I've always used these. And then you go back, once you get the wire pulled in, you put all your seals in. There's a fiber you stick in here, there's a fiber you stick in here, it's a dam. So this is going this way, so I have to dam up both sides. I can put in the plug, seal this off, and then fill it into here. You fill it up once it gets to the hole, and then you're done. Put your plug in, and you're done. We used to use a little stick and poke it and make sure it got in there real good. And then this is going up and down. Again, we get the fiber down at the bottom. We don't have to get it at the top. We only have to get it at the bottom. And you fill it in to a certain point. You still got to get the plug in, so make sure you don't fill it up past it and you can't get the plug in after the fact. The seal's we call it Chico. And you can use these to seal these areas in. Let me show you a little bit of. So here's the fittings. Depending which way you're going, and can change between manufacturers. So once you get your box in within 18 inches out of the enclosure, you have to have, and then you fill it in. Okay, and then you fill it in with the Chico. So you put the dam at the bottom, you fill it in, you put the plug on, boom, you're done. Again, this has to go within 18 inches of an enclosure. If you're coming out of the panel, if you're going from the panel to a box, guess what? You got to have one in the center. If you're coming out of that box again, then you have to have it again. So anytime you have an enclosure within 18 inches, you have to put one of these. Okay. This one here is a premix one. I'll send you a video on it. So these, you got it. This one here, this is a powder. Here's the seals. You fill in the seal, you fill in the hole, and then you mix this and you pour it in the hole. This one over here in the tube, that the guy right here in the picture, that one is, it's got the little mixing bar. Mix it, and then just pour it in. So no measuring to do. It's all pre-done for you. And there's talking about the Chico AP seal compound. I'll send you a video link on this so you can see how that works. Again, these are different seals, and again, it just changes between manufacturers. I'll be sending you an assignment that goes along with this video. I think it's got 6 questions on it, and this is yours today's assignment. Okay, again, here's a panel board, here's a motor starter, here's your stop starts receptacle. So anytime you come out of an enclosure, 18 inches from an enclosure, you have to have a seal. Okay, or you come in from one non-hazardous area to a hazardous area. Here's the inside of them. Okay, here's a motor. There's the light. Alright. So I'll be sending you some homework, and you can check it out. Alrighty. You have a good one.